So today we're looking at solving a system by subtraction. It's different than addition because we can't just add these up and make variables go away. If I were to add these up, I would end up with 6x, and this would be plus 1y, and that would be 11. And I still have two variables. I have x and y, so that's not very helpful. So we're going to take that away, and we're actually going to attack this problem a different way. First thing we need to do is we need to pick one of the equations and just leave it alone. And I'm going to pick the top equation and leave it alone. And the reason I'm going to do that is the 3x and the 2y and the 13 are all positive. So I'm just going to write it right over here. 3x plus 2y equals 13. The bottom equation, however, I'm going to change all the signs. When we see subtraction, really what we're doing is we're going to pick one equation and we're going to make it completely opposite, which means we're going to be changing the signs. And so this 3x here is going to become now, it's a positive here, it's going to be written as a minus 3x. This minus y right here is going to become a positive, so it's going to become a plus y, and if you want to write 1y, you can. And this negative 2 is going to become a positive 2, so equals and a positive 2. And now I can solve it by addition. So the purpose of subtraction is just one extra step of changing the signs. And the reason that you'll know when to use subtraction is because you'll see the exact same term, variable term, with the exact same coefficient and the exact same sign. These are both positive, 3x. So we needed to make one of them opposite. So when we add these up now, those disappear and you're left with 3y equals 15, and we divide by 3, and we have now half of our solution, y is 5. So if I want to go plug that in back to find x, that's our last step. I'm probably going to choose the top equation because everything is positive. So let's go ahead and take this top equation here. We'll have 3x plus 2y, but in place of 2y, I'm going to put 5, because that's what y is, equals 13, and that looks like 3x plus 10 is 13, and now I'm just down to a two-step equation, so I'll take away a 10 on both sides, and I end up with 3x equals 3. X is 1 after we divide, and that's it. So there's our solution. X is 1, y is 5. 1 comma 5 is the pair of x and y values. That would make both equations true. Let's go ahead and take a look at the next problem. So we're looking for the variables that have the exact same coefficient and they're the exact same sign. So you can see this one is a minus y, and so is this one. And so one of those has to change, and we have to pick which one wants to change to opposite. Now I'm looking at the other terms, and I'm noticing this is 4x and this is 8, and those are both bigger than the 4 here and the 2x here. So I'm probably going to leave the bottom one the same because I'd like to leave as many positive values as I can. So I'm going to just copy the bottom equation. You could change the top one or the bottom one, it doesn't matter, but I like to choose the easier way. I'm going to take this one here and I'm going to change every sign. So when I'm done here, I'm going to rewrite this equation. The positive 2x is going to become a negative 2x. And the negative y is going to become a positive y. And the positive 4 here is going to become a negative 4. And so now you can see that these plus y's and minus y's are now going to cancel out. So they're gone. And this is a negative 2 plus 4. That's just 2x equals 8 take away 4 is 4. And we divide by 2, x is 2. So it's just addition with one more step. So there's half our solution. It doesn't really matter which one I plug it into. I guess I'll plug it into the top one. 2x minus y is 4. I'm going to put this 2 right in there for x. So that's 2 times 2 minus y is 4. And that's 4 take away y is 4. And then you can see that when we take away a 4 here, this is a two-step equation, but I'm going to end up with a 0 on the right side. This is still a negative y. That's what's left. And you could divide by -1, but we're going to get the same answer even if you don't do that correctly. You're going to get y is 0. And so there's our solution. When x is 2 and y is 0, that'll make both equations true. We could actually do a quick check on this one because if x is 2, 2 times 2 is 4. 4 take away 0 is definitely 4, and 4 times 2, if I put a 2 in there, that's 8. 8 take away 0 is definitely 8, so we know that that's our correct solution. Let's go take a look at one more. You can see this one, everything is positive. We got to pick one to change. I'm going to pick the one that has smaller numbers and change it, so I'm going to leave the top one alone. I'm going to rewrite the top one, 3x plus y is 13. I'm going to copy the bottom one, but I'm going to change everything. So x is going to become a minus x, and plus y is going to become a minus y, and then equals. And you got to make sure to change everything. That'll be a common mistake. Students will often change things on one side, but not the other. That 5 has to change also. It's going to become a minus 5. And we can add them up. These go away. They're opposites. 13 take away 5, that's 8. 3x take away an x is 2x. And it's as simple as that. So x is 4 in this case. We can plug it back in. I could probably just do it right here. I know 4 plus 1 is 5, so that tells me right now that y is 1. I'm probably going to take the easy way out on this one and call this one 4, comma 1. You could also plug the 4 into the top one because 3 times 4 is 12, and 12 plus 1 is most definitely 13. That's why we know, we just confirmed that y is 1. Let's go ahead and jump down to a word problem here. So I'm going to help you set this one up, and we'll probably solve this one, and maybe I'll help set up the next couple of problems, and you can solve those on your own. 2 cars got an oil change, so you go get your oil changed at the same auto shop, so we can assume that they kind of charge about the same, and take a look at what they charge. They charge for each quart, and if I were trying to graph it, that would be my slope, because every time I add a quart, it's going to cost more. But they charge a flat fee for labor, so to change your oil, it doesn't matter whether you have a big car or a little car, they're going to charge you the same. So I guess we could look at this in equation and say, you're going to pay for oil and you're going to pay for labor, and together that's going to give you your total cost. And the labor stays the same no matter what, and it's just this oil that will change. So the oil change for one car, this is going to be one equation that we're going to be looking at here. So let's write our first equation. It says they got 5 quarts of oil. I'm probably just going to call that 5Q because I don't really know what a quart of oil costs. They get 5 quarts of oil, and the total cost was $22.45. So that's the oil, but we still have to write in the labor. So I'm going to write a L, or I guess I could call it X. So let's let labor for an oil change be X. So I pay for 5 quarts plus I pay X, which is my labor, and that total cost was $22.45. So I'm going to go ahead and put that there, $22.45. Now somebody else goes to get their oil changed. The oil change for another car is 7 quarts of oil, and so I guess I'm going to write that as 7Q. But they also had to pay that labor charge. They paid X, and that was their cost, $25.45. And now we need to go ahead and solve this thing, and you'll recognize right away that the 7 quarts and the 5 quarts is how it changes, but they both have this labor charge. And man, if I could take away the labor charge, I could figure out what oil costs. And so what we're going to do is we're going to look at the other terms in the first equation and the second equation. You notice that the first one, they have 5 quarts and it costs less. So I'm probably going to change this one because the numbers are smaller. I'm going to make that one everything opposite. So that's going to be a negative 5Q and a negative X equals a negative 22.45. And because those numbers are all smaller, I'm probably going to write this second equation. We're going to leave this one alone. This one right here, we're going to leave alone, but I'm probably going to put it on top so that I don't have to worry about looking at weird things and borrowing and regrouping. So let's call this plus 7Q and plus X and plus $25.45. And I was kind of careful to line up my place values so that when I add these up, because I just changed all the signs in the bottom one. That's the subtraction part. 7q take away 5q is 2q. There's no labor. The x's disappear. And 25, 45 take away 22. 45 is exactly $3. And when I divide by 2, Q is $1.50. So that means that for each quart of oil I buy, it costs me $1.50. So I'm going to go back and find the cost for the labor fee because I know how much each quart of oil is. So quarts of oil are $1.50 each. And we can just substitute it back in, and if you wanted to, you could even use the Desmos calculator. I don't know that the math is super complicated here. So 5Q, which I'm going to replace with $1.50. So 5 times $1.50. I'm rewriting equation number 1, by the way. 550 plus X, that's the X. I'm going to write plus X, which is my labor fee, equals $22.45. So I need to figure out 5 times 150. I'll do the quick calculation in my head. It's $7.50 plus X equals $22.45. And so now we just got to take away $7.50 and be done with it. So we got to be careful if you're going to do this on paper and not using a calculator. We're going to have to borrow here. So let's go 2, borrow from the 2 there, and that's going to make that 14. 0 from 5 is 5. So we got 95 cents, and 21 take away 7 is 14. So that's the labor fee right there. So, quarts of oil are $1.50 each. Labor costs $14.95. Let's go take a look at the last couple of word problems that are on your note guides, and let's set them up. I'm not going to solve them for you, though. I'll let you guys do that, but I don't think that these problems are all that difficult. If the numbers get too big, you can use a calculator if you want. Adult tickets. I'm going to probably use different letters on this one. I'm going to call that an A for an adult. And student, I'm not a big fan of using S. They look like 5s, so I'm going to call those C. So there's our students and our adults. And I know that adult tickets to a game, it says they cost $5 each. So if I buy 1 adult ticket, that'd be $5. And if I buy 2, that'd be 10, and 3 would be 15. And you're just multiplying them. So the total cost for adult tickets is just written as 5A because they're $5 each. And you can guess then that if student tickets cost $1 each, it's just 1 times C. So that right there is what you're going to pay on tickets. I don't care how many people go. A bunch of adults could go, a bunch of kids could go, and it's 5 times the number of adults plus 1 time the number of kids. And it tells you that a total of $2,874 was collected. Well, this is a money equation, and the only way they collected money was by selling $5 adult tickets and $1 child tickets. And it tells you also that we sold 1,246 tickets. And that means that I sell some, and this equation sometimes is a little bit harder to see. I sell some adults and I sell some children's. I don't know how many of each, but I sell 1,246 of them. Now, there's a lot of ways to add up 2 numbers and get 1,246, but there's only one way to get this kind of money, $2,874. So you can see that these are both 1C, and so you're going to have to subtract these 2 equations. And since the bottom equation has smaller numbers, this is 1A and that's only 1,246, I'm probably going to change this one. That means everything's going to become a minus. That'll be a minus, that'll be a minus, that'll be a minus. And maybe the hardest thing you'll have to do is subtract 2,874 and 1,246. So I'm going to leave that one alone. And I am going to jump down to the very last word problem. Let's take a look. It says the Baxter family bought 6 bags of roasted almonds and 4 juice drinks. And I guess I'm going to use A for almonds and J for juices. You could use drinks, I guess. Let me see here. I bought 6 bags of roasted almonds. That means I bought 6 bags of whatever I pay for almonds. And I bought 4 of the juice drinks, so whatever I pay J. So it looks like I'm trying to find the price of each thing. Find the price, find the price. So A would be the price of an almond drink, or almonds, and J would be the price of a juice. It says the Baxter family bought 6 bags of almonds, that's 6A, 4 bags or 4 juices, and $16.70 is what they spent. The Farleys, they bought 3 roasted almonds, that's going to be 3A, but they also bought 4 juices. And they spent $10.85. So I'm hoping at this point you would recognize that the juices are the same, and so we need to make those disappear, and the way to do that is with subtraction because they're both plus 4J. I'm probably looking at these 2 equations, and hopefully you can look at them and recognize which one has smaller numbers. That's the one we want to change. We don't want to work in negatives, so we're going to change the bottom equation to opposites. You know, that's going to be a negative 3A and a negative 4J and a negative $10.85. And the top equation is just going to be a plus 6A, a plus 4J, and a $16.70. And so, you know, when you add these up, your 4Js are going to disappear. And you're just left with 3A equals, and then you're going to have to subtract those out, which means you're going to have to borrow a little bit from the 6. You'll have to borrow 17 is going to have to get borrowed, 16, and that's going to be there, and you're going to have to get what? $5.85, and you're going to have to divide. So that's how that problem gets set up. I'll let you finish that up. If you wanted to use the Desmos calculator to do some of the work with the decimals, that would probably make it pretty short work as far as the subtraction and the solving and finding a solution goes. So good luck.